Okay, greetings. In this problem, we want to identify the density of sulfur dioxide gas at the conditions of 88 degrees Celsius and 1.4 atmospheres. Okay, so we're going to need to identify the information given in the equations that we were given. We know that density is equal to mass over volume, and I'll use a small m for mass. We know that for a gas, PV equals nRT. And we know that we can relate mass to moles with the formula weight. The formula weight is equal to the grams per mole, or the mass over the number of moles. Now, we're given the identity of the compound. It's sulfur dioxide. So I could go over to the periodic table, add the molar masses of sulfur and 2 oxygens, and I come up with 64.07 grams per mole. So what have I been given? I've been given the temperature, the pressure, and the formula weight. Okay? Now, let's start off with our calculation. Since we're solving for density, we might as well use the equation that has density as our starting point. So D equals m over V. Now, we need to substitute for m, okay? So I can come over here and I can say that the mass is equal to n times the formula weight, okay? So I can substitute that into here, and I get D is equal to the number of moles times the grams per mole, the formula weight, divided by the volume. Now I need to get rid of the volume. I can come over here, and I can see that if I rearrange the ideal gas law, V equals nRT over P. So I now substitute this into here, and I get that the density is equal to the moles times the formula weight all over the moles times RT over P. But P is in the denominator of the denominator, so I move it up to the numerator. Okay? Now my n's cancel, and I have my density is equal to the pressure times the formula weight over RT. I now substitute in the values. The pressure was 1.4 atm. The formula weight was 64.07 grams per mole. R is 0.08206 liters atmospheres per mole Kelvin. And T, remember we have to convert the temperature to Kelvin, so we were given 88 degrees Celsius, but then we have to add 273.15, and that converts this to Kelvin. Okay, my kelvins over kelvins cancel, my reciprocal moles over reciprocal moles cancel, my atmospheres over atmospheres cancel, and I'm given units of grams per liter. So my units are grams per liter, which is a unit of density, mass per unit volume. I get out my calculator, and I come up with 3.03 grams per liter, okay? And this way I've been able to calculate the density. Remember that it's a good idea to write down your equations that you're given, and start with an equation that has what you're after. And then just simply substitute in and keep track of your algebra and your units to make sure you come up with the right answer. Okay, good luck.